Let's say this is one JCL where we are just copying data from PS file 2 to file 1. Okay, and this is the same JCL where we are moving data from copying data from file 2 to file. Okay, let's say we'll take it as a file 1 only here. Okay, I submit this JCL now. This file got created, and the data whatever it is present inside this file 2 will get copied to file 1. It's done, right? Now again I am going to submit the same JCL again. I haven't changed anything. What will happen? Right. So if we schedule the same kind of job in production and we are trying to run the same job every day, then what will happen? First, one time it will run, it will get the file one will get created on that day, and the second day when we are trying to run, the job will get JCL error. Correct. To avoid these JCL errors, what we do is we will create GDG versions so that every day whenever it runs it will create new versions. The file name will be same. Only thing is when one job runs successfully, this generation will get created, and second day it will create this. Like on every day it will create one generation. Okay, that's the reason why we use GDG versions, GDG basis. So if we want to see if let's say three times the job run, so this is a version which was created recently. So if we want to use this file in our program or any recent file like fourth day it got created one more version, this we will represent with 0. Okay, and the previous version we will represent with -1. Likewise it will go. Okay, and if we want to create the new version, then we will represent with +1. Okay, now we will see how to create this GDGs. Here is the syntax, job card, and exec we are using PGM utility as an ID camps and sysin DD star. Why we use this sysin DD star? So sysin DD star, whatever statements we define inside the sysin DD star and slash star, okay, whatever statements we declare here, these are the statements we will be passing it to the program. This one program, right? ID camps is an IBM created program. That's what we discussed, correct? So whatever values we declare over here inside sysin DD star, this will get passed to this ID camps. So inside that ID camps, they will use these values. Inside the sysin DD star, you need to define GDG and name. So I will take this out from here and I will showcase you here. Okay, define GDG and inside that open braces, open bracket and close bracket, and inside that we have the parameters called name, which is used to specify the GDG name here. Okay, and then limit. So how many generations we need to create? If we are creating 10 here, what will happen? Until 10 generations it will get created. After that, what will happen? We will see that. Limit 10 generations it will create. Okay. We can give 10, 20, 30 as well. No issues in that. Limit how many generations if you need on the screen, to view those many generations you can provide over here. Next, coming to no empty or empty. Empty, what it will do, it will uncatalog all the generations once a limit reached. So, once the 10 generations get reached, right? Let's say this job ran for 10 days. So 10th generation got reached. Okay. Next 11th generations. After 10th generation is getting reached, what will happen? All these 10 generations will get uncatalogued. That is called empty. It uncatalogs all the generations one limit reached. No empty, it uncatalogs only the oldest generation once limit reached. So empty and no empty, the difference is empty. What if we provide empty here? What will happen? It will delete all the 10 generations. I mean, uncatalog all the 10 generations. You know, right? What is uncatalog means? Catalog and uncatalog. Catalog means just we are storing this dataset's information in some other dataset. So when we are providing this dataset name to access, it will directly go find the details in that catalog and it will go fetch the data from the dataset. In case if it is an uncatalogued, if it is uncatalogued, then we need to provide volume, serial number, and every all the other details as well to fetch the data from this dataset. So if we are giving empty, then all the generations which has the limit whatever we have provided, right, 10. So all the generations till now whatever it got created will get uncatalogued. If we are providing no empty, then what will happen? Only the oldest generation. Let's say if we are creating 11th generation, what will happen? Only this generation will get uncatalogued. Rest all will be there. Like 10 will be there. Always 10 generations will be there. But oldest generation will get uncatalogued. Now, if let's say 12th generation got generated, then this generation will get uncatalogued. Again, 10 will be there so that we can go ahead and view the data. That is the difference between empty and no empty. Empty, it will uncatalog all the 10 generations so that only the 11th will be available. But no empty, only it will uncatalog the oldest generation once the limit is reached. Next, scratch and no scratch. What is the scratch? It deletes uncatalogued generations. No scratch, it won't delete uncatalogued generations. That's it. So, if we are providing scratch here, it will delete the uncatalogued generations. Let's say if we are giving empty and scratch, okay, for some data set we created this way, empty and scratch. What will happen? So after the 10th generation got created, it will hold. And once it starts creating the 11th generation, what will happen? Empty means all this generation will be uncatalogued, but the data will be present and data set will be present, right? But to access those, we need to provide volume and unit parameters, everything. That is called uncatalogue. So if we are by giving empty, what will happen? All these 10 generations will get uncatalogued. But again, if we are giving scratch here, scratch means it will delete all uncatalogued generations, right? So that whatever uncatalogued generations, the 10 datasets which got uncatalogued will get deleted permanently. That is called scratch. If we are giving no scratch, so the dataset will be present, but it will get uncatalogued. So you can't go ahead and view the datasets directly. So here, what are the default parameters are no empty and scratch. No empty and scratch are the default parameters for creating a GDG dataset. Why no empty scratch? No empty means it will not delete all the generations. So once the limit is reached, let's say once the limit is reached, only it will uncatalog oldest generation. If we are creating one more here, if I am creating one more here, let's say 13, then what will happen? It will uncatalog the oldest generation, 3. And scratch, what it will do? It will delete that oldest generation. So every time we will have only 10 generations which will be available to view. Okay, that is why we have one more point which we added as an users here. It will delete or uncatalog oldest generations. So we don't need to go ahead and delete or create the files over here. It will automatically take care. Clear about GDG base and GDG, okay, GDGs. So here again we have instead of taking 10 generations, I will take 3 so that it will be easy for us to identify how it works. Okay. So since we have the continuation parameters over here, we are giving hyphen over there. Okay. Now I will submit it. So it ended the GDG base created successfully. So, when I am discussing about this GDG, I am just discussing about sometimes GDG base and sometimes GDG versions, right? So, what is GDG base is once we create this, so if you see, this is called GDG base, okay? So, you can't weave anything over here, it's just an base. We can use or create the GDG versions only after creating the GDG base. Once we create GDG base, then only we can give the names over here like this. We can't directly go ahead and create the versions. Okay. Once we need to first thing is we need to create GDG base, and then after that we can create generations under the GDG base. Clear? Now we will take this GDG base and create generations. Now if you see, here there is some file one, right? We do have this file one or we deleted it. Okay, file one contains some data over here. That's fine. And what we are doing, we are trying to copy some data to this GDG base with logical record length 50. Okay, let me go ahead and submit it. Max is 0. Now I will go ahead and see that generation now. I am just clicking enter. REF. See, one generation got created. If we go ahead and view the data set, whatever data present in that, it got copied over here. Clear, na? Now what I will do, I will go ahead, submit it once again. In case if we are using normal flat file over here, I mean PS file, it should throw an error, right? If I am submitting it again, stating the duplicate data sets. Now I am submitting it again. See, it got created again. F3. I'm refreshing this. So see, again one more generation got created. Again, I will go ahead and submit it again here. Third generation got created. Function pf9. Again, I will submit it. Now we will see. See what we did there while creating the GDG base. What is the limit that we provided? Limit we gave it as an 3, correct? So only 3 generations will be available. So see, if you see, we submitted the job for 4 times. So fourth generation also got created over here, correct? But since we provided no empty and scratch, no empty means what it will do? It will uncatalogs the oldest generations. When this fourth generation is getting created, it will uncatalog the oldest generation, which is G triple zero one V double zero. It's an oldest generation. And scratch what it will do? It will delete that uncatalogued generation so that the generation 1 got deleted. Now, this is the oldest generation now, right? If I submit it once more, so this generation will get uncatalogued and this generation will get deleted. And fifth generation will be available. So anytime you can only keep 3 generations. You can view all these 3 generations. Version 2, version 3 and version 4. Any doubts in this GDG creation? Versions also you are clear, right? Okay. Now altering GDG definition. Sometimes there are situations where we need to change the attributes of GDG. These types of tasks can be performed using alter command. We'll use IDCAMS utility to alter GDG attributes. Okay. So if we want to change something in the GDG base, like we want to change the scratch to no scratch or empty to no empty, then all these things we can do it by altering it. So let me go back. Alter GDG, we have a program here. So until sysint dd star, everything is same. It's the same program. But inside this, instead of define GDG, we'll give alter GDG. Previously, what we gave? Define GDG and in brackets name, limit, no empty and scratch and close brackets, correct? Now what we are doing? Alter GDG and GDG base name we have provided here. Okay. The syntax is alter and we will directly give the GDG base name. No need to mention GDG here. Okay. Alter GDG base name and then limit 5. So it went successfully. Now what we'll do, we'll try to submit that. So I don't want to go back to that program again. So what I will do, I will come to this pool. Here we have the JCL, right? So I will submit it again. So what is this happening? Now GDG version we are creating one more time. We'll give ref. See here. Now previously only we were able to create three generations, right? When we are trying to create another generation, it used to get deleted. But since we altered the GDG base to limit 5, we were able to see one more version as well here. I will submit it again, and here, see, sixth version also we can see, and the oldest version is still not uncatalogued or deleted. It's still there. Now the limit we gave it as an 5. So let's see one more time. See, now the oldest generation, which was version 2, it got deleted. Generation 2, it got deleted, and now we have 5 generations here.